Hello everyone. So the homework is page 159, 1 through 9 odd, and I'll be working on sample problem number 7. Okay? So let's take a look at number 7 here. Number 7. So we have this three system linear equations and our job is to get x, y, and z. Okay? So let's do that. So number 7. So we have x plus y plus 2z is equal to 3. 2x and plus y plus 3z is equal to 7. Negative x minus 2y plus z is equal to 10. Okay, so we have our three equations here. And our job is to get what x, y, and z are. Those are what's called solutions. So what's the first step we want to do? Well, we have three variables. Let's get those three variables down to two variables. So we want two equations with two variables. Okay, so two equations with two variables. So let's call this equation 1, equation 2, equation 3. Which two do you want to do? Well, notice that x looks pretty easy to cancel, y looks pretty easy to cancel. We could choose x or y. So in this example, I'm just going to choose y. Okay, so I'm going to eliminate y. I'm going to make two equations with just the x and z variable and then with the y gone. So let's do that. First thing I'm going to do is I'm going to choose equation 1 and 2. And then I'm going to choose equation 1 and 3. Okay, so let's do 1 and 2. Actually, let's do 1 and 3 and then 2 and 3. 1 and 3, 2 and 3. So I'm going to rewrite 1. I'm going to rewrite 3. Okay, so I want to eliminate the y. The x looks pretty easy to eliminate here, but since we said y, we're going to just stick to the y variable. Now notice that if I add them, the y's do not cancel. So what do I have to do to it to make the y cancel? Well, I can multiply the top by 2. So let's do that. I multiply the top by 2. So then what I get is 2x plus 2y plus 2z is equal to 6. 2x plus 2y plus 4z is equal to 6. And the bottom one, I just simply rewrite it. Minus 2y plus z is equal to 10. And if I add them together, the y's cancel. And what is 2x minus x? That's just x. And what is 4? There it is. What is 4z plus z? That's plus 5z. And 6 plus 10, 16. So we got our first equation with the y gone. Now we have to go back and choose another equation to get rid of the y. So we said it was 1 and 3. So now let's do 2 and 3. Let's do 2 and 3. So I'm rewrite 2 and 3. Equation 2 is 2x plus y plus 3z is equal to 7. And I'm just rewrite equation 3. Negative x minus 2y plus z is equal to 10. And once again, I want to get rid of the y. How do I do that? Well, I gotta multiply the top by 2 again, because that will make it 2y and the negative 2y, they cancel. So the top will then become 4x plus 2y plus 6z is equal to 14. And the bottom, I just simply rewrite it. And once again, I add them up, and I end up with negative 2y, they cancel. 4x minus x is 3x. 7z plus z, 6z plus 7 plus z is 7z. 7z, sorry, should be a 7. And then that's equal to 24. 14 plus 10 is 24. So I got my two equations now. I got my first equation here, x plus 5z, and I got my second equation, 3x plus 7z equals 24. So then I put them together and I want to eliminate another variable. So let's do that. X plus 5z is equal to 16. And then 3x plus 7z is equal to 24. Once again, if I add them, the x nor the z cancels. So I gotta multiply the top by something. Since I want to eliminate the x, I'm gonna multiply the top by negative 3. Because that will make it negative 3x, and 3x, they can cancel very easily. So if I multiply the top by negative 3, what does my new equation look like? It'll just be negative 3x minus 15z equals, what's 16 times 3? Negative 48. And I just simply rewrite the bottom. 3x plus 7z equals 24. Once again, when I add them, the x cancels. And what is 15z minus plus 7? That will be negative 8z equals, what is negative 24? That means negative 48 plus 24. That will be negative 24. Divide by negative 8. Divide by negative 8. Z is equal to 3. So we did all that work just to get z is equal to 3. So are we done here? And the answer is no. We have z, but we have to go back and get y and x. So I'm just going to put a box around it. So we got z. Now, can we plug into the original equation to get y and x? The answer is no, because there's still two variables here. So what we're going to do is we're going to take the z and we're going to plug into the one of the ones that we solved already with the y gone. So we can either plug into x plus 5z equals 16, or we can plug into 3x plus 7z equals 24. Because if we plug in z, then we can solve for x. So this looks easy, and it does not matter which one you plug it into. So I'm going to plug into this one because it looks pretty easy. So I'm going to plug in the z in for here. So I get, I'll write it right here, x plus 5z is equal to 16. And I plug the negative 3 in for z. So we get x plus 5 times 3 is equal to 16. X plus 15 is equal to 16. Minus 15 minus 15, x is equal to 1. So now we have x is equal to 1, and we have z is equal to 3. Now we can plug into one of the original equations and solve for y. So equation 1, 2, 3, it does not matter which one you plug into. So I'm going to plug into the first one because it looks a lot easier. So we have x is equal to 1. So I'm going to rewrite equation 1. That's equation 1. And then I'm going to plug in what we know. X is equal to 1. So 1. We don't know y. So that's y. Plus 2 times z. What did we say z was? Z is equal to 3. Is equal to 3. And now we just simply simplify. 2 times 3, 6 equal to 3. And then what's y? 1 plus 7? 1 plus 6, 7. Y plus 7 is equal to 3. Minus 7 minus 7. Y is equal to negative 4. So now after all this work, we solve for x, which is equal to 1. We have y, negative 4, and we have z, 3. So our full answer, remember, it's always going to be in the form of x, y, z is equal to, what is x? 1. Y, negative 4. And z, 3. And that is our final answer. Okay? So if you have any more questions, please let me know tomorrow in class, okay? And have a good night, everyone.